Hi, everyone. We are Team 13, and this is our second project for data science and big data. We initially set out to classify news articles as real and fake, and these are our key findings through the course of the project. First and foremost, we were able to identify actual fake news articles as fake, and we see this adds a lot of value in terms of not just saving human lives, but also saving the general public opinion. We see one interesting thing that we found about news articles was that they tend to have longer titles, whereas their actual length of the news articles is a lot more variable than real news articles. We also found that the topics of fake news articles they tend to change over time. So we did train our data from news articles from the years 2015 to early 2018. And the topics changed from presidential elections to financials to foreign policy and finally to the COVID-19 outbreak that we'll see towards the end of the presentation. And we did use three models during the course of our project, and Random Forest was the best of them. We got FN score, which is 99.7% and almost a perfect ROC area under the curve for the ROC curve. Yes, so this is our, like going back to the title of the proposal, this is what we set out to do, classification of fake news articles. It's me, Abhishek, and Jake as well. Um, Talking about social media, this is something that has aggravated the problem of fake news articles. So this was a problem which was it was persistent for a long time, but social media has just made it worse. And the reason for this is anyone with internet connection and a little bit of imagination is now capable of writing and maybe proliferating fake news.
So, in terms of fake news, getting into a bit of the background, it's easy to think that most forms of fake news might be just harmless disinformation, but in many cases, human lives can be lost. For example, there was an instance in which the terrorist organization Boko Haram kidnapped over 200 school-aged girls in Nigeria. And initially, the government dismissed the kidnappings as a hoax, and their rescue was delayed until much later. A photo from Boko Haram surfaced showing that some of them were alive, which prompted the government to finally take action. And they were able to save some of the girls, but unfortunately, over 200 had died. So that makes detecting fake news and preventing those kind of delayed responses very important. And the ways that we have to detect fake news now are essentially by manual fact checking, which is slow and hard to automate. So there's a need for a fast, flexible, and automated method that, for example, social media websites are able to employ in order to filter out these kinds of fake news. So looking at the characteristics of our data, we had two CSV files. One was of 21,000 real news articles and one was of 23,000 fake news articles. They ranged in time from March 2015 to February 2018 and are originally from PolitiFact, which is an independent fact-checking organization that classifies news articles as fake on a scale.
So when we set out to explore the data, we did have a few expectations, and this is one thing that did meet our expectations. What we see here is the actual number of fake news articles. It consistently outnumbers the number of real news articles. Starting from January 2016, we see the number of fake news articles was almost 5 times higher than the number of real news articles, and we see a similar trend going all the way through August 2017. Something that did stand out and something we found was of great value was that the length of these titles was a lot higher. So fake news articles they tend to be a lot more variable in length in terms of the titles and also a little longer. And the reason we found this after a bit of research was that real news articles are governed by industry standards. So all major media companies and journalism as a profession, they tend to keep the headlines to be as short as 10 words. And this is something that's missing from real news, from fake news articles, sorry, because it's not governed by any industry standards and it's not professional journalists who write them. And this is something we found consistent with our expectations. And finally, we did try and see if we could find some correlation as to if the number of news articles goes up. Does it mean that people are releasing a lot of short fake news articles? But we didn't see any correlation there. So what we see here on the first graph is the number of real news articles versus the median of the text word count. The reason we chose median was that it's a little more robust to outliers than average. So what we see here is that if the number of news articles goes up, it doesn't mean the word count would go down, and the same is not true vice versa. And when we talk about fake news articles, we see although the number of fake news articles is higher here, there's no correlation to the word count again. The number of fake news articles could go up, and the median count could go up or down, and basically one is not predictive of the other.
So getting into our model building, again, our objective is to build a classifier that can classify whether an article is real or fake. And we had three classifiers: k-nearest neighbor, support vector machine, and random forest. In all cases, we used cross-validation to find the best hyperparameters for each model. And we measure our performance with F1 score in order to maximize the number of true positives that our model is predicting. And we visualize our performances with an ROC curve and precision recall curve, which we will see on the next slide. So looking at the ROC curve on the left, random forest outperformed both of the other models, just barely beating support vector machine. And both random forest and support vector machine greatly outperformed k-nearest neighbors. And looking at the precision recall curve, we can see that random forest outperformed both support vector machine and k-nearest neighbors. So for that reason, we consider random forest to be our top performer, and that's what we use for further analyses. So after training our model on the full data set, we wanted to sort of test the value added by taking text from an actual fake news article on the web that it hadn't seen and seeing what our model predicts about that. And these three articles that we tested were more recent. So whenever we did that, the predicted percentage of being fake was 51%, 52%, and 65% respectively. So in all cases, it predicted correctly that the articles were fake, but it wasn't extremely confident in those predictions. And we attribute that to sort of a change in topic over time in the fake news. So for example, one of them was about the COVID-19 outbreak, which are all topics that our model had never seen because these things didn't exist at the time that our data set takes place. So in other words, our model has sort of high internal validity, but low external validity. So our model provides value because it's able to predict the probability of being fake on news related to Trump and the presidential administration and foreign and financial affairs from that time, but it needs data on new, more recent topics to be externally valid. And that's our main finding. Thank you.